All right, this next video, we're going to talk about the shapes of distributions when we compare the mean and median of the data. So let's zoom in on the first one. The first one is what happens to the shape when the mean is greater than the median. And to compare them, we're going to go up to distribution number 3. Distribution number 3 is an example when the mean is greater than the median. So the mean right there is greater than the median. And we can see that the data is really clustered on the left side, but then I get this tail on the right. When you get a tail on the right side, that's because the mean is greater than the median. And what we call that, I'm going to scroll back down, and you're going to write this right down in your notes, is, there we go. And we say that that's skewed to the right. When I get that tail to the right, that means it's skewed right. So distribution 3 is skewed to the right because the mean is greater than the median. All right, let's move this over. And let's see what happens when the mean is actually less than the median. For that, we're going to go up to distribution number 2. So I'm going to go up to distribution number 2. And in distribution number 2, I can see that the data is really clustered on the right side, but then I have this tail on the left. In distribution 3, the tail is on the right side, but in distribution 2, the tail is on the left side. When the tail is on the left side, we call that skewed left. And skewed left happens when the mean is less than the median. So let's go back down to your notes. What happens when the mean is less than the median? And this time, instead of skew right, we're going to say that the data is actually skewed to the left. So just make sure you're writing that down in that box, that the data is skewed to the left. As I'm playing with the mouse. There we go. So mean less than median, skewed to the left. Beautiful. Let's move this over one more time. Awesome. What happens when the mean and the median are almost exactly the same or they are the same? Let's go up to distribution number 1 to take a look at that. So if I go up to distribution number 1, I'm going to change my pen color to green really quick. There we go. We can see that the data actually forms a symmetrical little, almost like half, not a half circle, but you can see it's symmetrical, almost like if I just draw a little dotted line, like right down the middle of the data, like that, it looks like half the data is to the left, half the data is to the right. It's pretty symmetrical. We would say that that data actually has no skew. It's not skewed left. It's not skewed right. There's no tail to the left. There's no tail to the right. All the data is really clustered in the middle, and then it starts getting less to the right, and it also starts getting less to the left. When the data is clustered in the middle, we say that this data has no skew. So let's go back down to your notes. We gotta hit the arrow to do that. There we go. Go back down to your notes. And where it says shape of distribution when the mean is approximately the median, when they're close to equal to each other, we call that, come on, bear with me a second. What is going on with this mouse? There we go. Nice. We call that no skew or symmetrical. Thanks for bearing with me for those 10 seconds there. That was weird. So when the mean or median are almost exactly the same, the data has no skew, and we say it's symmetrical. So those are the 3 different shapes you might see. You might see something having skew to the right, skew to the left, or having no skew. The next and last video I'm going to post has to do with multiple choice questions you might see on a quiz or a classwork and what they look like.